Jai Hind all. Very good morning to all of you. In the lecture series of Power System 1, and this power system is very important for the third year uh, and the final year students of electrical engineers, uh, and it is beneficial for their interviews and the competitive examinations. So, in the lecture series, the new topic is overhead line insulators. Actually, this topic is covered in the class in a detailed way, but somehow I feel that the overview and the some glimpse of overhead line insulators is to be given in a brief way. So this is a important point which I will discuss with you all. So I will start. As for the as far as the content is considered, the first one is what are the types of insulators and their applications, their structures, designing parameters, and etc. This is suspension insulator string. After that, we will see the string efficiency. What is the use of taking the string efficiency in account of transmission lines and the overhead line insulators, and what are the methods and what are the formulation of to calculate the string efficiency, and what are the different types of methods to improve it. So if we see, the first question is arises, what is insulator? So an insulator defines it's basically a support to the overhead line conductors on the poles to prevent the current flow towards earth or ground. And in the transmission line, it plays an essential role in power system operation and controlling part. So insulators basically is, which are supports to the overhead line conductors on the poles to prevent the current flow towards the ground side or a earth side. The designing of an insulator can be done using different materials like rubber, wood, plastic, mica, etc. There are different types of materials are exist in our surrounding in our nature, which is used for the different types of designing of insulators, rubber, wood, mica, etc. The special material used in the electrical system are ceramics, glass, PVC, and steelite, and the polymer, etc., etc. So these are the points which we see the introductory part of what is the insulator and what is the definition and what is the designing material of it. So these are the introductory part. But the most common material used in the insulator is a porcelain. This is very important point. This question may be asked in a interview and as well as competitive examinations like SSC, JEE, UPSC, and other public service commission examination as a multiple choice questions. Which type of material is used for the insulator as a special purpose, and this also a special composition stellite glass materials are also used, but the porcelain is the most important special material. And if we see the function of insulator, so we'll see an insulator is one kind of material where the internal electric charge of this does not run freely. So insufficient electric current will run through in the power of an electrical field. So this is the function of insulator, and the other one is insulation breakdown. So we all know that the what is breakdown voltage. So we will see, once breakdown voltage is applied to the insulator, then it will become conductive. So this is known as the insulation breakdown. This phenomena is important. So in the next part we will see the different types of insulators. So these are classified into different types based on their ratings, and which includes the following. They are used in transmission and the distribution system. So there are several types of insulators, such one is pin insulator, suspension insulator, stain insulator, shackle insulator, disc, post, and stray polymer, and the glass insulator. There are the different types of insulators used. So if we talk about the insulators and their designing and their ratings, so the first one is pin insulator. This kind of insulator is used, I am talking about the pin insulator. This type of insulator is used in the distribution system, and the voltage capacity of it is 11 kV. 11 kV. It is designed with a high mechanical strength material. It is designed with a high mechanical strength material. These are connected in vertical as well as the horizontal positions. So this is the feature. These are connected in either horizontal or vertical positions, as far as the alignment and the application is considered in the transmission and the distribution side. The construction of this insulator is simple and needs less maintenance as compared with other types. So this type of insulator is used in so many applications. The pictorial diagram of pin insulator is like that. This is the pin insulator. Other insulator is shackle insulator. These insulators are small in size, used in overhead distribution systems. The connection of this insulator can be done by using a metallic strip. Basically, it contains a metallic strip. So here we see the metallic strip, which you will see in a real time physically side. The voltage capacity of this insulator is 33 kV. So the voltage rating of a insulator is typical values, and which is to be remember when you will go for a any application side, which type of insulators to be used for your applications. So depending upon the voltage level in the transmission and the distribution side, we use our suitable type of insulator depending upon the applications. So the voltage capacity is 33 kV. It works in the positions of band or circular turn. At present, these insulators are used as strain insulators, but they are used in less voltage distribution lines. And these insulators are used in a vertical position or horizontal positions. These are connected to the pole using both otherwise and the cross arm. This is also used as a vertical and a horizontal position. So this is also feature of like that as a pin insulator. So this is the pictorial diagram. This is a regular insulator. Other one is disc insulator. This insulator is just like as a disc. This is known as a disc insulator. It provides a cost-effective solution for a medium and low polluted environment. And these are designed with high grade raw materials. This is the feature of it. And these are well known in the broad market because they are mostly used in the transmission and the distribution lines. This type of insulators we can easily see in our daily life, and the overhead transmission lines in the distribution and the transmission system as well. The applications of these insulators include transmission lines, industrial, and also commercial point of view, because they have highly efficient features like less corrosion, robust design, and higher effective. So the efficiency of it is greater. It supports conductors used for insulation in cables and electrical wiring and maintaining high voltage within high loads. So this is just like as a disc. So this is a disc insulator. Other one is strain insulator. So this is similar to suspension type insulator because it is used in overhead transmission line system, but its specification and working are somewhat and somewhere different. So this is actually used in the most of the transmission lines, and it is placed in the band, otherwise the arm places. And the pictorial diagram of it, the strain insulator is just like that, and the voltage level is similar with the other than the disc insulator, actually 33 kV, and the strain insulator has also the voltage level, the typical voltage rating of about 33 kV. Suspension insulator. So this type of insulator called disc insulator, and the designing of these insulators can be done using a material like porcelain or a glass, which I have discussed earlier. This is a special type of material which is used in the insulator, and the voltage capacity of a suspension insulator ranges from 11 kV to 765 kV. This is very important voltage range, and this may be asked in your external examinations. This is also useful for and possibility of being a question in your interviews as well as your competitive examinations to tell about the voltage range of suspension insulator. So it is 11 kV to 765 kV. It is used in a overhead transmission line systems by providing more flexibilities. These are used in a very broader way. It is used in a industrial and commercial applications also. It uses various discs based on the level of voltage is connected to by using the steel tars, so it needs more height to support to all the discs. These insulators are most helpful compared with the other insulators, because if one disc in the insulator gets damaged, so then remaining all the discs will work properly. This is the feature of. So the damaged disc can be replaced with the others. So this is a very important and easily used for industrial and the commercial applications as well. And one point is to be remember that the voltage rating is 11 to 765 kV. So we will see the potential distribution over a suspension insulator rings. So we will see this is the earth shower, and we will see the support. This is the earth tower, and this is the cross arm. And these are the conductors and the insulators as well. And this is the metallic link. Yeah, metallic link or chip. Yeah, strip. So the equivalent circuit of 3-disc string insulator is like that. So this is the ground or earth, and this is replaced by a capacitor C, KC, 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 and this is the first branch, second, and the third. So the potential across the first arm is first level is that is V1, and for 2 this is V2, for third this is V3, and the capacitors are placed in a branch in this way. So we will calculate the voltage, current, and after that we will see the string efficiency. These are the shunt capacitance, which is to be calculated as K into self capacitance. So potential distribution over a suspension insulator string. So we will see from the above equivalent circuit applying KCL law. KCL, Kirchhoff current law. There are two laws, KVL and the KCL. In the KCL we will see. This diagram is already we discussed in the previous slides. So we will see. So first of all, this is V1, V2, V3, and the capital branch currents is this is I3, I2, and I1. So we will start in a stepwise. So first of all, I2 we will consider this point. So I2 equal to I1 plus I1. So this is small I1 and this is capital I1. So what is I equal to V by Z, yeah, V by R. So I equal to V, and what is Z? If we see the capacitance, so with the reactive capacity V by XC, and this is V, and XC equal to 1 upon omega C, so V omega C. So if we talk about the I2, so V2 omega C equal to V2 omega C for that, and I1 V1 omega C plus V1 omega KC, because K is a factor for a, we will see यहाँ से shunt capacitance equal to K into the self capacitance. So V2 omega C equal to V1 omega C plus V1 omega KC. Just like that, V2 equal to V1 plus V1 plus V1 K, because omega C to be cancelled out. So omega C only K will appear. So V2 equal to 1 plus K of V1. So the voltage across second branch V2 equal to V1 of 1 plus K. And in the other side, we will see the potential distribution over a suspension insulator string. So applying the KCL law at node B. So in this case, I3, this current is I3. So I3 equal to, what is I3? I3 equal to I2 plus I2. Here I2, a capital I2, and is the summation of I2. So we will see, we will apply the KCL law which applied in a previous case, just like that. So V3 omega C equal to V2 omega C plus, what is I2? V2 plus V1 omega Kc from the first equation. So V3 equal to V2 plus V1 plus V2 of K, and V3 equal to K V1 plus 1 plus K of V2, and V3 equal to K V1 plus 1 plus K square V1. V3 equal to V1 of K plus 1 plus K square. V3 equal to V1 K plus 1 plus 2K plus K square. So the final V3, the voltage across the branch 3, V3 equal to V1 in the bracket 1 plus 3K plus K square. This is the result of V3. So we have V1, V2 and V3 values. So now voltage between the conductors and the earther tar is V equal to V1 plus V2 plus V3. So V equal to V1, and what is the value of V2? 1 plus K of V1. And what is V3? B1 of 1 plus 3K plus K square. So overall total voltage V equal to V1 of 3 plus 4K plus K square. So from the above equations, first, second and third, which I have discussed in our previous slides, it is clear that the voltage across top disk is minimum, while voltage across the disk nearest to the conductor is maximum, that is V3 equal to V1 of 1 plus 3K plus K square. As we move towards the cross arm, voltage across the disk goes on decreasing. It's a important point, and it's that's a point may be asked in your interviews and your placement drives, and exactly for your multiple choice questions. So the question may be like that: what will be the effect when we move towards the cross arm? Voltage across the disk goes on decreasing. So this question may be asked. Other side, due to this non-uniform voltage distribution across the string, the unit nearest to the conductor is under maximum electrical stress and it's likely to be charged. So this is the potential distribution over a suspension insulator string. And if we wish to calculate the string efficiency, so in this equivalent circuit, we have seen the voltage level of V1, V2 and V3. So the string efficiency is to be calculated as the voltage across the whole string divided by N into the voltage across the unit adjacent to the line conductor. So NS, that is string efficiency, equal to the voltage across the whole string, that is V1 plus V2 plus V3 equal to V. So that is V, and N into voltage across the unit adjacent to the conductor is, that is V1. So greater the string efficiency, more uniform is the voltage distribution. This is very important point which is to be remembered. Greater the string efficiency, more uniform is the voltage distribution in the uh, potential distribution side over a suspension insulator string, as well as to see the string efficiency for the calculation. So in the other side, we will see the different types of methods which are used to improve the string efficiency. In the previous slides, we have discussed, we have analyzed, we have instructed that what is string efficiency and what is the use of it, and what is the detailed procedure and the formulation of it. So in this case, we will see the three types of methodologies to improve the string efficiency. First one is by using the longer cross arms. Second one is by grading the insulators, and third one is by using a guard rail. So in the first case, first one is by using the longer cross arm. So in this case, the value of string efficiency depends upon the value of K. The ratio of shunt capacitance to the mutual capacitance. What is K? K is the ratio of shunt capacitance, that is Kc, and mutual capacitance or the self capacitance, that is C. So K is the ratio of shunt capacitance to its mutual capacitance. The lesser value of K, the greater is the string efficiency and more uniform to the voltage distribution. This type of points are very useful and insightful for your interviews questions. The value of K can be decreased by reducing the shunt capacitance. It's also a very important point. The value of K can be decreased by reducing the shunt capacitance. In order to reduce shunt capacitance, the distance of conductor from tar must be increased. I am repeating it. In order to reduce shunt capacitance, the distance of conductor from tar must be increased. That is, longer cross arms should be used. So this method is used by using longer cross arms. And however, limitation of cost and strength or power do not allow to use of very long cross arms. In practice, K equal to 0.1 is the limit that can be achieved by this method. So this is the pictorial diagram. This is tower, or you can say support levels. These are the shunt capacitors, and these are the insulators and the conductors, and this is the link metallic strip, and this is the pictorial diagram. So in the other case, by grading the insulator, this is the another technique. So in this method, the insulators of different dimensions are so chosen that each has a different capacitance. In this case, the capacitance is different. So insulator of different dimensions are to be taken into consideration to choose, as each has a different capacitance. And the insulators are capacitance graded, that is, they are assembled in a string such a way that the top unit has the minimum capacitance, so increasing progressively as the bottom unit, that is, it is nearest to the conductor. In this case, the voltage is inversely proportional to the capacitance. Voltage is inversely proportional to the capacitance. So this method tends to equalize the potential distribution across the units in the string. And this method has a disadvantage that a large number of different size insulators are required. So it is very crucial to use a different types of insulators into account of this method. So this is the disadvantage of it. And the other one is by using a guard ring. This is a very important consideration, guard ring. So a guard wire is used. This is guard ring. The potential across each unit in a string can be equalized by using a guard ring, which is a metal ring, which is electrically connected to the conductor and surrounding the bottom insulator as shown in the figure. This is guard ring. It introduces capacitance between metal fitting and the line conductors. The guard ring is connected in such a way that the shunt capacitance currents I1, I2, etc. are equal to metal fitting line capacitance, that is current I-1 and I-2. These results is that same charging current I flows through each unit of strings. Consequently, there will be a uniform potential distribution across the units. The result is same charging current I flow through the unit of string. And this is the pictorial diagram. This is shunt C1, C2, and here is the guard ring. So this is the guard wire basically, which is connected to the bottom of the conductor. So these are the different types of methods for calculating to and improving the string efficiency. So in today's lecture, we have seen the different types of insulators used for the transmission and the distribution side, and what are the potential distribution over overhead light insulators in the string efficiency, and what are the different types of methods to improve the string efficiency in the overhead transmission lines systems. So thank you so much.